So curve has a function y equals x minus 3. I'll just write the question down quickly.
Okay.
So if we expand the bracket, we get 7x minus x squared minus 21 plus 3x, and this equals minus x squared plus 10x minus 21. And you can do the dy by dx here, so that would equal minus 2x plus 10.
Correct. Part 2.
Okay, find the equation of the tangent at the point 6, 3. Okay. So point 6, 3. That's the point we're given. And the original equation is minus x squared plus 10x minus 21. Okay. Would we sub the x value of 6 into this equation?
Correct.
Right, okay, so H2. Find the equation right, so if we sub in 6 there, we'd have minus 6 in a bracket squared plus 10 times 6.
So that would get you y, which they told us is 3. How would we go about getting the equation of the tangent?
Okay. A tangent is perpendicular to the gradient at a certain point.
That's a normal, so that's the next one. So tangent, the gradient is parallel.
Okay. Could you explain this for me, please?
Okay, so what form will our answer take?
It would be an x squared plus b plus c.
The equation of a tangent?
Oh no, just something x plus something. So ax plus b.
Yeah, so in general it'll be y equals mx plus c.
Right, yeah, sorry.
And so
yeah, I think I know what to do here. Plus c. So yeah, now I remember. So the y coordinate we're given is 6 and the x is 3. So 6 equals so 6 equals 3 times m plus c.
Okay, the problem there is you don't know what m is, so I'd find m first and then use that to find c.
Okay.
How do you find m?
Okay. We'll find so would we use the dy by dx?
Correct.
And if value -2 here?
Say it again, sorry.
So would you just get -2 for the m value, or is that?
How did you get -2 for m? Because it's -2x.
Right. Okay. Actually, no. I think I have a different idea. So if dy by dx equals -2x plus 10, if we just use the x coordinate we're given, which is 6, -2 times 6 plus 10.
Yeah.
And that gives us -2. Is that our...
Yeah. And then you would find c.
Sure. Just a general question. When I originally thought of -2, I just thought of it because it was in front of the x value for the dy by dx, but that's not right, is it?
No.
Okay. Okay. So,
yes.
yeah. So then we have the y value to be equal to 3. So y equals mx plus c.
And just continue with that for a second. Let's be a second. And do you want to check if you're ready? Sorry about that. Did you get a value for c?
Yeah, I got 15 for c.
Okay, and so equation of the tangent?
So y equals -2x plus 15.
-2x plus 15. Yes, so the other stuff is just an equation of a line. In general, dy dx is called the gradient function. It's like a formula for finding the gradient of the curve at a point. So let's say, what is the gradient of this curve on the left side of it? What do you know about it?
Do you mean the one you drew here?
Yeah, that little sketch.
Okay.
What do you know about the gradient of the curve on the left side?
The gradient is a -x squared.
No, I believe the gradient would be positive here, wouldn't it? Like this tangent has a positive gradient.
Oh, right. Oh, do you mean at that point?
Yeah.
Okay, so that would be a positive gradient.
And what if the tangent was on the other side?
That would be a negative gradient.
That's it. And let's say right at the very top.
That would be 0 because it's just a straight line across.
Yeah. And so the gradient of the curve, so a line always has the same gradient.
Yeah.
A curve, the gradient changes, and so dy dx gives you the gradient of the curve, a formula to find it at a specific point. You have to sub in that point to get the gradient of the curve at that specific point. But in general, it's just a function or a formula for finding the gradient at any specific point.
Yeah.
And you'd have to specify. 9, I think, is just, it's supposed to be difficult because they use difficult numbers, but it doesn't really seem like it's very good. Let me just see this. State the gradient of the tangent at Q. Yes, this looks good. Wait. Find the equation of the tangent at the point. Do they mean P? Must be. Okay, so how would we do this?
Okay. I might just draw that sketch quickly.
Okay. just be a sec. Okay, any idea about this one?
Okay, so the equation of the tangent at that point. First thing, I'll differentiate this. So the gradient function would be, so dy by dx equals 2x minus 1. And at the point 2, 1, we know the x value equals 2, so we can sub in 2 there. So 2 times 2 minus 1 is 3. And that's our coefficient of x. So y equals mx plus c, y equals 3x plus c, and use the coordinates again. So 1 equals 3 times 2 plus c, 1 equals 6 plus c, and then c is equal to minus 5 here. So we have the gradient would then be y equals 3x minus 5.
Well done. That's it. So there was more to this. So these are now the type of questions that will come up for this, and so we should tackle it. Although they don't involve calculus. So how could you get this one, part 2?
The normal at a point Q on the curve is parallel to the tangent P. State the gradient of the tangent Q.
So basically state the gradient of the normal at a point Q. The normal at a, so there's a different point Q is parallel to the tangent at P.
I think it will be the same. So if you have the curve on the other side of the curve, there'd be a point somewhere.
Yeah.
And then that would just be parallel to that the P there.
So this, I'm just going to do a more standard. Okay, so this is the normal. What would be the gradient of the normal?
That would be the negative reciprocal. So tangent is this. Normal is y equals minus a third x minus 5.
Okay, so the gradient. What would be the gradient of the normal?
Minus a third x.
Minus a third?
Yeah.
It won't be minus 5. You would have to go, again find the c for this one.
Okay, so y equals minus a third plus c. 1 equals minus a third times 2 plus c. c equals 1 plus 2/3. So I'll just leave that as a fraction. So that would be 5 over 3. So y equals minus a third x plus 5 over 3.
Yes, that's it. Okay, so that would be the equation of this blue normal. And they just ask a very kind of different question. So any idea about their question 2? So there's quite a tricky question.
Yeah, so if we draw a straight line kind of parallel to the x-axis from P until a point on the curve, like where it would meet, somewhere there. If we leave that as our point Q, there'd be, what is it? The gradient of there's a normal that's parallel to this point. Okay, so you could kind of imagine the normal parallel to the tangent on P.
Mm-hmm.
And the gradient of Q. If the normal is parallel, we know the gradient has to be the same, but it's got a different y-intercept.
Mm-hmm.
So
what would the gradient be?
the gradient would be 3x. 3. M is 3.
Okay. And then we have to find the coordinates of Q.
So y equals mx plus c. Y equals 3x plus c. I'm making the assumption that if this is kind of like so this would 2x plus c. The y value.
What do you know about this Q, about this normal?
The normal, I guess the only thing is it's parallel to P.
Okay. How can you use that?
The gradient is the same, so 3x. But I don't know what else to do.
Not enough. So basically, if its gradient is 3,
yeah,
and you did dy dx for that point,
yeah,
you would get 3.
Okay, so yeah, so dy by dx of something, so 2x minus of 3. So the dy by dx equals 3, and it should equal I'm a bit stuck, to be honest.
So basically 2x minus 1 equals 3 for that point.
How do we get the 2x minus? Oh, right, because okay. I think because the original dy by dx. Okay, so dy by dx equals 3. Dy by dx also equals 2x minus 1.
Yeah.
So we can just get the x value here. So 2x minus 1 is 3. 2x is 4. X is 2. So that x value here is 2. Y equals 3 times 2 plus c.
You don't need to find the equation of the line. What does the question ask you to find?
The gradient of the tangent at Q.
So that's question 2. Question part 3.
Oh, right, sorry. So find the coordinates of the point Q. Okay. So we have the 5 is our x value here. And then we need to find the y value. The gradient is y equals x squared minus x minus 1. Y equals x squared minus x minus 1. So y equals 5 squared minus 5 minus 1. That would give us 19. So the coordinates would be 2, 19. 5, 9.
When x is 2, y equals x squared minus x minus 1. And you said x is 2?
Well, so would we just sub in 2 for the x value?
Yeah. And
Okay.
that will give you y.
Right. But the 5 I got before from getting 3 times 2? Oh, no, that doesn't... That's not...
It's on a different line. Yeah.
Okay. Right. Okay, so that would just be... Yeah, we'd have 2 there. 4 minus 2 is 2, minus 1 is 1. So the coordinates would be 2, 1.
That's it.
Yeah.
No. That's P. Wait. So of course it works that way. But wait a second. Oh. No. Right. Why did this question have to be so tricky? Dy dx gives you the gradient of the tangent. They said this was the gradient of the normal. And so what? So it would be like that. And so what would be the gradient, or what would be dy by dx at the point Q?
That would be the tangent.
Yes.
So we actually have to... so we have 2x here, so it would be minus a half that we'd use for the coefficient of x.
No. The gradient of the normal is 3, so the gradient of the tangent?
Minus a third.
Yeah.
Okay.
And so what could you do to find the x coordinate?
Okay. The gradient of the tangent is minus a third.
Mm-hmm.
So we could say that... okay, so... So 2x minus 1 equals minus a third?
Yeah.
Right, so 2x equals 2 thirds.
Mm-hmm.
So x would equal just 1/3.
Yeah.
And we sub that into the original equation.
Mm-hmm.
So 1/3 squared minus a third, 1, which equals 1/9 minus 1/3 minus 1, which is, we'll have them all over 9. So 1 minus 3 minus 9 all over 9, which gives us minus 11/9. So the coordinates would be a third minus 11/9.
Okay. Yeah, because when we did it the first time, we just rediscovered the point 2, 1.
Okay.
You know, when the gradient is 3, dy dx is 3, and that's that point. Yes, so the kind of big picture to this, I mean, there was lots of double negative, you know, the normal, the gradient, you know, flipping from one to the other. But the big picture is, to work in reverse, if you know the gradient at the point, you can make that equal to the gradient function and then work in reverse to get x.
Okay, I'll just write that down. So if you know the gradient,
function.
Gradient function at a point, was it?
And the gradient at a point.
Okay. At a point.
You can work in reverse to find the x coordinate of the point.
Could you explain the question again? Is that all right?
Yeah, so it's just basically so if you say dy by dx, and that's equal to some function, and I'll just do function dash x. And you also know that dy by dx is equal to some number a, then the f dash of x is equal to a, and then solve for a.
Okay.
Sorry, then solve for x. And so the f dash of x could be anything.
Right.
So it could be of the form mx plus c, it could be ax squared plus bx plus c. So something that you would know how to solve.
Yeah.
And then just work in reverse. Okay, let's see if we remember this type of stuff. I'll try these two hardest ones, or maybe I should just increase. I will see. So question 1. Okay, any idea how we do these?
Y equals x squared plus 4. Okay, so y is x squared plus 4. What does it mean by increasing?
So for this graph, on the left side, so here on, let's say on the right side, here the gradient is positive, here the gradient is also positive, but it's more positive to the right. And so on the right side, it is increasing. On the left side, the gradient is going down, so it's decreasing. Then it has 0, and then it's going, yeah.
Okay. The call kind of froze, like just mid-explanation. Sorry,
sorry.
Could you say that again? Sorry.
Yeah, so maybe I'll just take in this picture. Okay. So on the left side, the function is decreasing. On the gradient of the function is decreasing. On the right side, increasing. And so you can see how on the right side, here you have positive gradient.
Yeah.
Here you have a bigger gradient. And so it's increasing.
Right.
So the rate of increase is increasing.
Okay.
And same on the left side. On the left side, it's decreasing.
Yeah. But the rate of decreasing is also like decreasing as well. Okay.
Yeah, so the rate of decrease is decreasing here, the rate of increase is increasing.
Yeah.
And so for this you will have to use the double derivative to get the rate of change.
Okay.
So gradient gives you rate of change. dy dx is just rate of change.
Okay.
So this one here.
The first one, we're given the y. So dy by dx is 2x.
Mm-hmm.
We need dy, so d squared y over dx squared,
Mm-hmm.
which equals just 2, I think.
And so work out the values for which the following functions are increasing. So Any idea about that?
Alright, so the values of x. I double differentiated, I don't know if that's the word, but I did d squared y over dx squared for the first one, and yeah, I've got 2, so it's x0 here.
I believe so. Let's try this one here.
Okay. Two x minus 4, and then d squared y over dx squared is 2. That's 2. Yeah. I got 2 for the answer here.
And so you got 2x minus 4. Let me just see. You know what the lowest point on the graph?
Yeah.
How could you find the coordinates of the lowest point on this graph?
That would be, well, we use the dy by dx, but that equals to 0 at that point. Because the gradient's 0. So 2x equals 4, so x would be 2. 2, yeah, x would be 2.
So this graph would look something like that.
Yeah.
So here, the minimum point, x is 2, and so will the function be, where will the function be increasing in terms of x?
When x is greater than 2.
That's it, when x is greater than 2. And so for this one here, to be an increasing function, so it's when that is greater than 0, so when x is greater than 2. Yeah. Okay, so now let's try these tricky ones.
Yeah.
Are decreasing. We'll just try a cubic one.
Okay.
So let's try second last one. And this is decreasing.
Decreasing. Okay, so v triple I. Y equals 2x cubed minus 3x minus 72x. So dy by dx equals 6x squared minus 6x minus 72. So d squared y over dx squared equals 12x minus 6. And that function, is that equal to 0?
So that would give you the coordinates for the lowest point. If it's a decreasing function, then I believe you would say it's just less than 0.
Yeah.
Because it's decreasing. So 12x minus 6 is less than 0, and then you just solve for x.
Okay, right. So yeah, so 12x would be less than 6, so x would be less than 2. Okay.
So that's it. X is less than 2. And if you were to make this equal to 0 and solve it, I'm sure x would be 2, and you would have to kind of maybe sketch the graph, but this way is much easier.
Okay.
And maybe we'll just try. So that was a decreasing cubic. So we'll just look at increasing cubic. And this is kind of a strange one.
It's an increasing function for all x values. So we just find the double derivative. So dy by dx equals 3x squared minus 12x plus 27. So d squared over dx squared. D squared over dx equals 6x minus 12. And if it's an increasing function for all the values of x, that would be greater than 0.
Okay.
So that means that 6x is greater than 12. X is greater than 2. And perhaps if we sub in the 2 for the original equation, we get a... I don't know, actually.
I'll just give you the y coordinate.
Yeah.
Okay, sub in 2, see what you get.
Y equals 2 cubed minus 6 times 2 squared plus 27 times 2 minus 4, which equals is 8 minus 24, 8 minus 24 plus 44 minus 4. 8, 24 minus 16. 16.
They went about it a different way. Go on, what did you get?
I'll just type that in the calculator. So 8 minus 24 plus 44. That gives me 24.
Okay.
So basically, x has to be greater than... So y has to also be greater than 24.
8e question 4. This is page 190. Page 190. Question 4. Oh, okay. So they wrote it in completed square form, and they just said it has to always, like, x always has to be positive or greater than 0. No, question 4. Is that? Did I take in the right question?
Yeah.
That's just totally different. Page 194, 190. Oh, that's activity. Just the answers just don't seem to match up with the question even slightly. Am I doing something wrong? So I should go up to question 5. That goes up to question 5. Oh, okay. So they differentiated it.
Yeah.
And then they put it into completed square form.
Right, so you have 3 outside the bracket and then x minus 6 inside the bracket squared. 6 times 6, 36. 36, so minus 9 outside the bracket. Okay. And what does that tell us?
Let's see. So 3, and then in perfect square form, x minus 2 squared minus 2 Is that what you had?
Yes, yeah, I got that.
And so 3x minus 2 squared minus 6 plus 27, so plus 21.
Yeah, yeah.
So what is the minimum value you can get here of this whole thing? Do you know?
Minus 6 squared, 21. So the minimum value would be 21 here. Yeah.
Yes. And so
Yeah.
basically this whole thing will always be greater than or equal to 0. And in fact, greater than or equal to 21.
Okay.
And therefore, and that is dy dx.
Yeah.
Is greater than 0 for all values of x, like no matter what x is. And so therefore it's an increasing function for all values of x.
Okay.
Okay, so that's this prove type of question. You find dy dx and then you put it into completed square form.
Okay.
I still think, what was the double derivative?
6x minus 12.
6x minus 12. I think the way you would do this is 6x minus 12. No, it doesn't prove it. You would say is greater than or equal to 0. No. No. It wouldn't prove it. Yeah, the way you prove it is putting it into completed square form. Okay. And then just show that dy dx is always greater than or equal to 0.
Okay. Could you just
No. That's not. I don't like that. The gradient. I think it would have to be, to show that it's always increasing, d squared y by dx squared would always have to be bigger than 0, wouldn't it? Because that's the rate of increase.
Yeah.
And so you would have to show that 6x minus 12 is always greater than or equal to 0, but that's not what they did. Let me just go. So plus 27 for all values of x. So they did it. Okay, so the way they proved it was by saying that dy by dx is always bigger than 0. Seems like dy by dx could be bigger than 0, but it could be going down.
Yeah.
Maybe because it's a cubic or something. Oh, I don't see it. I think... So definitely what would prove it would be if d squared y by dx squared was always greater than or equal to 0.
Yeah.
Then it's definitely always increasing. And in fact, not equal to 0. It would have to be just greater than 0.
Yeah.
But apparently, for some reason, if you show that dy by dx is always greater than or equal to 0, then that means it's always an increasing function for all values of x. And you do that by putting it into completed square form.
Sure. Okay.
All right. There you go. Let's see. Stationary points. So we did this a little bit already. I just want to go to let's see, classify the point. X values. Yes, this is a good one. Okay, how would we do this?
Okay, so y equals x cubed minus 12x plus 3. And then dy by dx is 3x squared minus 12. And that equals to 0. So 3x. Right, we'd have to kind of factorize this. 3x and x. So we'd have two brackets basically. Multiples of 12 are 3 and 4. So if I just break, so 12 is 3 times 4, 2 times 6, 1 times 12. That's it. And they have to multiply to give 3. Is that right? Wait. One of them to multiply by 3 and then have to give 0. Yeah, so we'd have 3x plus 6 and x plus 2.
So it's basically 3x plus 2 and x minus 2, is it?
Yeah, I think that. Okay, yeah.
Or you can do it the other way. But it's basically 3 times something makes 0. We know that 3 isn't 0.
Yeah.
And so it must be the other thing that's equal to 0. In this case, you could do it as two things or you could do it as one.
Right, okay. So you could say that, I think your method's actually easier because what I did was I tried to find multiples of 12 that both, that when one of those numbers is multiplied by 3 and added to the other number, it gives 0. So I think that's a bit more difficult. So as you said, 3 and x squared minus 4, was that? And then equals 0, so 3 x plus 2, x minus 2.
Yep.
So x equals minus 2, or x equals 2.
Or x equals 2.
Yeah.
What does this mean? Classify the points on the curve with these x values.
Classify the point of the curve. Oh, I think it means where on the curve are those x values found?
It means which one is the maximum, which one is the local minimum.
Oh, because it's a cubic graph, right? Okay. I'll draw that.
I mean, I've just done a little sketch, but they're just basically asking which one is the max, which one is the min.
Okay, so would the maximum be 2 and then the minimum be minus 2?
So according to my sketch, the maximum is the one on the left and the minimum is the one on the right.
All right. Yes, so the maximum would actually be minus 2.
You can actually check. What would be d squared y by dx squared?
That would be the rate of change. The rate.
Rate of change?
Yeah.
And so what is the function for this one?
The dx squared. That equals 6x. Yeah, 6x.
Okay, and so for the respective x values, when x equals minus 2, when x equals 2.
Okay, so then 6 times minus 2, is that what you do?
Yeah.
Okay, so that'd be minus 12.
Okay, so that one is minus 12.
So we'd have minus, what was it? Minus 2 minus 12 for one coordinate.
No. Basically, d squared y by dx squared, if it's minus 12, so in that case it's less than 0. If d squared y by dx squared is less than 0, that is a maximum.
Okay. Right.
If d squared y by dx squared is greater than 0, it's therefore a minimum. And so this is kind of, we've proven it rather than just kind of sketching with a graph.
Yeah. I honestly didn't really get that. Could you?
What would be d squared? okay, so maybe. So if we just look at our graph for a moment, at a maximum, what's happening to the gradient as you approach the maximum?
All right, so the gradient is slowly getting smaller.
Yeah, and then as you approach the minimum, what's happening to the gradient?
It's increasing.
Correct. And so basically, when d squared y by dx squared is less than 0, it's that's the maximum point. When
Okay.
d squared y by dx squared is greater than 0, that's a minimum point.
Okay.
And I believe...
Sorry, just let me copy that. So that is maximum. The minimum. And I'll just write a little explanation. So, d squared. So if it's less than 0, that means the rate of change. Change is actually getting smaller each time.
Say that again, sorry.
So the rate of change is getting smaller like each time.
For which one?
For the maximum.
Okay, yeah. So it's decreasing.
Yeah. The rate of that would be decreased.
Okay, yeah, that's one way to think about it.
Yeah. Okay. Yeah. Don't worry about. No. Continue what you were going to say.
So maybe I'll just do English between them. Each of these. So let's try this one, question 2. So find the stationary points and say which is which.
Okay, so the dy over dx is so that would be 6. So that would be 12 plus 6x minus 6x squared, and then d squared y over dx squared is minus 12x plus 6. So what are they after again?
So the 2 points, so when that's equal to 0 and you solve it, x equals 2 or x equals minus 1. So those are the 2 stationary points when dy dx is equal to 0. How do you figure out which is the maximum, which one is the minimum?
Okay, so it has to be, the dy by dx has to be less than 0 for it to be a maximum. Or if it's greater than 0, it would be a minimum. So the d squared y over dx squared is minus 12x plus 6.
Okay.
12x plus 6. And if we sub in 2 and minus 1, 12 times 2 plus 6 is 18 minus 8. That would be less than 0. Minus 12 times minus 1 plus 6 is 18, which is greater than greater than 0.
I'll just be a sec.
Yeah, sure.
And so what did you get for those, Stefan?
Right. I got minus 12 times. So if we use the 2 as the x value, you get it to be less than 0, which is a maximum point. So the 2 value would be maximum, and the 1 value would give us a minimum.
That's it. And if you look at the sketch, because this is a minus x cubed, minimum is on the left and maximum is on the right.
Right.
And so it kind of makes sense.
Yeah.
Yeah. How was that for you, Stefan?
That was good. I think I got that.
Anything in particular you want to do next time?
If we could, because I've got a test this time next week on calculus for further maths. Could I just have a look at like how much we've kind of covered this level, if that's all right? Just book, like if there's much left.
So the point of inflection is when it's equal to 0. We covered everything, I think.
Oh, that's great. So next week we can continue with further maths as normal.
Okay.
Yeah. And also, did you want to see the 2018 maths challenge that I did?
Yeah, you can email it to me if you like.
Yeah. I didn't get anything for it though, I don't think.
Because
because the teacher marked it because they photocopied the mark sheet, and I didn't. Yeah, I don't think I got it. So.
Well, maybe next time.
Yeah.
Well done, Stefan. You're doing great. I look forward to talking again next week.
See you next week. Thank you.
Have a good week. Goodbye.
Bye-bye.